Good morning, guys. It's still morning. My name is Lucian, and I will be your tutor for today. Okay, I see I have three other guys with me in the session so far on Teams. That would be Masefo, Lalita, and Lifa. Welcome. I'm gonna start soon. Can you just on Teams tell me if you can hear me? By in a show of hands. Give me a thumbs up. Okay, thanks. Thanks, guys. I have put up the revision questions that we'll be doing so far. Number one, two, and three is visible there. And on we will be doing some basic stuff you have done before. You should know by heart now, but uh, it seems that you guys are having problems with these concepts. Concepts like conversion of units. Okay. It's conversion of units, order of magnitude calculations, what exactly is an order of magnitude, and then the final one, significant figures. Okay, those things should become uh, basic. They should be instinctive by at this point, but it seems that a lot of students still have some problems with. You guys can put down your hands now. Uh, it should be instinctive by now. You should know it off by heart. Thank you, guys. But it seems that there is still some confusion regarding these concepts. Okay, so I'm going to do a few problems on these concepts and hopefully cement some of these concepts. And if not, then make you understand them better. Okay, I'm just gonna wait until 11 o'clock. I'm doubtful that anyone else is gonna show up, but if they do, I said 11, so I'm gonna start in 5 minutes. Okay. Something right down here. And starting next week, I will be using the whiteboard. Usually, I prefer writing on paper as I understand stuff and I can actually write out my thought process. But I'm going to start using the whiteboard instead of actual paper. But for now, let's just wait until 11 o'clock strikes. And those of you who did turn on yesterday, my apologies. I don't know if it was the rain or weather or what was happening, but I couldn't access. The Wi-Fi was down. I could not access anything, so I had to come in today to do the session. Oh, you can read the first question so long. It's pretty easy. Okay, most people will be able to handle it, and all three of you will most likely be able to answer it. But like I said, some of these things are not being adhered to in tests, tutorials, and exams. Okay, and your exams are getting very close now. Okay, it's April, May, then you're writing your exam. I think we can start now. This is the revision session, and our first topic we'll be discussing is conversion of units. Okay, conversion of units. Okay. Welcome, Tebatsu. Hey, we're gonna start now. Just let me know if you can hear me. Tabatsu, let me know if you can hear me. Our first topic is on conversion of units. Okay. Now, conversion of units is very integral to physics because most of the time you're not going to be using SI units, so you're going to have to convert to SI units. Okay. Like, and most of these books that use textbooks were written by the Americans who prefer their system, the empirical system that they have. Don't know why they don't switch to the metric system, but anyway, that's a debate for another day. You need to know how to convert between units, and a lot of people always try to memorize, should I divide by 1,000, should I multiply by 10,000? That is completely unnecessary. Okay, you do not have to memorize anything when it comes to conversion of units. Okay, if you know what one is in this unit and how much it is in another unit, that's all you need to convert between. So if you know that 1 gram is, or 1 kilogram is 1,000 gram, that's all you need to convert between kilograms and gram. Or if you know that 1 ton is 2,000 pounds, that's all you need. You don't need to memorize anything when converting between units. Okay, so for example, let's start with question number 1. And I'm writing with a Koki today so that I can write nice and big. Okay. Question number 1 says, or it asks, a solid piece of lead has a mass of 23.94 gram. Okay. So 23.94 gram is the mass of a piece of lead. Okay. And it has a volume of 2.10 cubic centimeters. Okay. So we have a mass and a volume. The mass given in grams and the volume given in cubic centimeters. Now, they tell us from these data, calculate the density of lead in SI units. SI units for density is then kilograms per cubic meter. Is kilograms per cubic meter. Now, what is the formula for density? We know. Remember, this has got nothing to do with density. This problem is on the conversion of units. Okay, the conversion of units. Okay, they want us to write the density in terms of SI units, which is kilograms per cubic meters, but we are given volumes in cubic centimeters and we are given mass in grams. Okay, so first of all, what is density? Density is equal to mass over volume. Okay, that is density. Now, going further, we've been given that the mass is, let me just write this longer, the mass is 23.94 grams. Write it this way. I might need a piece of that page. So this is the mass, 23.94. And the volume that we've been given is in cubic centimeters, okay? And that is 2.10 cubic centimeters. That's the volume we've been given. Okay? How do we convert from grams to kilograms? Because we need kilograms here, okay? firstly, what you do is the following. Now, let me write it this way. This might get confusing, the two pages. I write it this way. Density is mass over volume. And then we just want to make this line longer. I'm going to write the same thing. We have the mass is 23.94 grams. And we have that the volume is 2.10 cubic centimeters. That's the mass, that's the volume. So that would be the density. If we were to calculate the answer, it would be in terms of grams per cubic centimeter. But the question clearly asks us to state it in SI units, which is kilograms per cubic meter. Now, a lot of students would then go and panic about, how do I convert cubic centimeters to cubic meters? How do I convert, well, grams to kilograms is easy, but they would then ask, how do I convert cubic centimeters to cubic meters? And start stressing about that. Is it divided by 10,000? Is it divided by 100,000? Is it divided by 1,000? There is no need to memorize any conversions. All you need to do is the following. Okay? All you need when converting between two units is what it is in one unit and what it is in the other unit. Okay, those of you guys who just joined, I see quite a few just joined right now. Welcome. We are doing the problem that is on the board there. It says revision of chapter 1 concepts. And I am writing with a Koki because I find that it helps me to explain my thought process. But coming next week, I will be doing it on the whiteboard. Some of you prefer that, but so I'll be doing that. If you have a question, please ask. And for those of you who just joined, quick recap, we're going to be calculating the density. Okay, but we've been given the mass in grams and we've been given the volume in cubic centimeters. So we need to convert to SI units, which is kilograms and cubic meters. Okay, now of course you could have done the conversions before you actually do the calculation. That is perfectly valid. Okay, but sometimes you don't have that time. You can just do it in one calculation. Okay, now how do we convert grams to kilograms? Can someone please tell me, how do you convert grams to kilograms?
Divide by 1,000.
Divide by 1,000. Was that a lot of people? I don't know which one, because all of you are lighting up now. Your mics just turned off. Whoever said that, thank you. You are correct. You divide by 1,000. Okay. Now, when converting from one unit to another, is all you need to know is the relationship between those two units. Okay, because you would, if the unit you want to get rid of, you will always write underneath as the denominator. Okay, you will always write it as the denominator. Remember, you want to get rid of grams, so you will write grams underneath here. You know that 1,000 grams is equal to 1 kilogram. You know that. As long as you know a relationship between one, you could have said here 2 kilograms is equal to 2,000 grams. That would have been perfectly fine, as long as you know the relationship between units like that. Okay, so you know that 1 kilogram is equal to 1,000 gram. Okay, and check this out. Grams will cancel out, leaving your answer on top in kilograms. Okay, and if you look at it mathematically, it's going to be 23.94 multiplied by 1 divided by 1,000, exactly as one of you guys just said. You divide by 1,000. Okay, that is how you do conversion of units without looking at or memorizing anything. Let's look at this one here. Let's look at this one here. This one always trips people up. volume, whenever it's to the power of 2 or to the power of 3 or to the power of 7, it doesn't matter. The same principle applies. First, you need to know a relationship between centimeter and meters. Can one of you tell me a relationship between centimeter and meters? Okay. How many centimeters in 1 meter?
100.
Okay, Lifa. Cool. There is 100 centimeters. Now remember what I said earlier on. You always write the units you want to get rid of in the denominator. So you're going to write here centimeters. The unit that you want to get rid of, remember here centimeters, you want to get rid of centimeters. So you write it in the denominator. Now in the numerator, you write the unit that you actually want, which is meters. Okay. Now you just told me, Lifa, that 100 centimeters is equal to 1 meter. That's it. That's all you need to know to convert. Okay. But remember, it is not just centimeters, it is centimeters cubed. So all you do is you just cube the whole thing. That's it. You cube the whole thing. Does that make sense? You just cube that whole thing. So far, by a show of hands, who has been following me? Okay, but just by a show of hands, you've understood what I tried to explain so far. Just a thumbs up or whatever. Okay, cool. Now, here, remember here, you are writing meters on top and centimeters in the denominator. But never forget, you're working with centimeters cubed. So you need to cube this whole conversion unit here. Okay, let's continue. What you're left with on top will be an answer in kilograms. So it's going to be 23.94 divided by 1,000. That just means 1, 2, 3. So it's going to be 0.02394 kilograms. Okay. I know this sounds very basic at this point, and I assure you it is, but some of you have problems with the stuff, the basic stuff. And then underneath, remember to square here. Okay, you need to cube, so square to cube. Now 1 cubed is just 1, and 100 cubed is, check out the 100 cubed, it is a 1 with 6 zeros. So it's 1 with 6 zeros, so it is a million. So it'll be 2.10 divided by 1 million. Okay, that will give you your answer in cubic meters. Okay, so let's divide it by a million. Let's just get my calculator here. Or I can have just done this. If you do this whole sum, you will get eventually to this answer 2.110 times 10. You don't actually need to go do divide by a million times 10 to the negative 6. That means divide by a million. Okay, and this is in cubic meters because this cancels centimeters cubed, cancels with centimeters cubed, and what you're left with is meters cubed. So your answer here is in meters cubed. Now if you divide that, you get the following answer. The answer is 1.14. You can check this out. 1.14 times 10. If you see here, 1, 2 times 10 to the 4. You can actually work this out in your head if you are brave enough, but try using a calculator and your answer will be in kilograms per cubic meter, which is what we wanted. Okay, we have an answer in kilograms per cubic meter. Okay, so now you have learned how to convert from, remember the answer was never about density, it was about conversion. Okay, during a calculation. Okay, so conversion. So now you know how to convert. All you need is the following. You need a relationship between the unit that you have and the unit that you want. So if you have grams and the unit that you want kilograms, you need a relationship between those two. For instance, we know that 1,000 grams is equal to 1 kilogram. You just need one relationship between them. You could have said 2,000 grams is equal to 2 kilograms. Then what you do is you make a fraction of those two, and in the denominator you write the unit that you want to get rid of, and then in the numerator you write the unit that you want. Okay, and then the relationship between those two, in this case 1 kilogram is equal to 1,000 grams. Okay? That is how you convert from a unit that you don't want to a unit that you want. Okay, that is how we were able to convert both mass and volume to our desired units. Okay, let's continue. I'm hoping everyone is with me with that point at this point. Okay. Okay, let's say question 2. It's still conversion of units. Okay, then we're going to do order of magnitude and then significant figures. Let's say 2. We have, let me just highlight the question and remove the highlight from the other question. This is the question we're doing now. So, oh, okay. I temporarily just removed the question, but it's back now. Okay. So, an ore loader, okay, can be either a truck, it is a bulldozer, basically. So an ore loader moves 1,200 tons an hour from a mine to the surface. Okay, so an ore loader, either it can be a machine as well. It moves 1,200 tons or tons per hour from a mine to the surface. Okay, now they're telling us convert this rate to pounds per second using 1 ton is equal to 2,000 pounds. Okay, so first you need to know that what is speed. It is just, well, in this case the speed is tons per hour. Okay, it moves 1,000 tons per hour, 1,200 tons. Moves 1,200 tons per hour. That's what this ore loader is moving. But then they tell us that we need to convert it from tons per hour to pounds per second. Okay, so first we need to convert, or another way of writing 1,000 tons per hour is as follows: 1,200 tons per hour. Okay, so we need to convert tons per hour to pounds per second. Okay, now first we need to convert tons to pounds. Okay, so we'll be multiplying. What relationship did they give us to convert from tons to pounds? Okay, they tell us there that 1 ton is equal to 2,000 pounds. Now remember what we said earlier on. Okay, the unit that you want to get rid of, you write at the bottom, in this case tons. That is 1 ton is equal to 2,000 pounds, which is LB. Why it is that, I have no idea. Okay, so 1 ton is equal to 2,000 pounds. That means ton will cancel and our answer will be in pounds. Okay, now we need to get rid of per hour. Okay, per hour into seconds. I should have written that underneath, but some of you might confuse. Okay, so in 1 hour, first we want to get rid of the h. Okay, so we'll write it, in this case the h is underneath the line, so we'll write it as the numerator. So 1 hour is equal to 60 minutes. 1 hour is equal to 60 minutes. Now we want to get rid of minutes. 60 minutes, or 1 minute in this case. 1 minute is equal to 60 seconds. So this is how you would convert from, let's just ignore this part. This is how you would convert from tons per hours to pounds per second. Okay, you know that to get rid of tons, you need to write it in the denominator. Okay, so 1 ton is equal to 2,000 pounds. How do we know that? It's given. Okay, now we want to get rid of hours. Okay, we know that 1 hour, in this case, if you want to get rid of hours, you write it in the numerator, because in this case it is in the denominator. So if you want to get rid of hours, you write it in the numerator, because in this case it is in the denominator. So if you want to get rid of hours, you write it on top, but then you convert to minutes. Okay, 1 hour is equal to 60 minutes. If you were to leave it as thus, if you were to ignore this, your answer would be in pounds per minute. But we don't want pounds per minute, we want pounds per second. So in order to get rid of minutes, we know that 1 minute is equal to 60 seconds. That would give us our answer in pounds. What is left? We see hours will cancel. Hours cancel with that one. Minutes cancels with that minute there. And what we're left with is pounds per second. Okay. Now, if you were to do this whole calculation, your answer will be in pounds per second. Okay. The numerical calculation would then be 1,200 multiplied by 2,000. Let's do it quickly on the calculator. 1,200 multiplied by 2,000 multiplied, or not multiplied in this case, if you look here, not multiply, it is now divided by 60. Multiplied by 60 again, because this is seconds. That gives you 666. So 666.7 pounds per second. That is how much ore is moved in pounds per second. So 600 pounds, 666.7 pounds of ore is moved every second if we are moving 1,200 tons in an hour. So that is a bit more difficult than the first one, but still doable. Okay, the next one is similar to the one that we just did. It is all conversion of units. Okay, question number 3 will not be long in this session. Question number 3, if you have any questions, just by a show of hands. I know Lifa, Masejo, then someone didn't write their name, Lucanio, Puche, Sianda, Lucanio again. There are 2 different Lucanios here. Viewer, all of you guys, just by a show of hands, okay, do you understand what I just did? The first 2 problems. Give me a thumbs up or a thumbs down. Okay, cool. Okay, it seems the two of you that responded understood what I was doing. Okay, so now we have question number 3. Let's see. Let me just they tell us here, assume it takes 7 minutes to fill a 30-liter gasoline tank. Okay, calculate the rate at which a tank is filled in gallons per second. Okay, so what is rate? It is just basically speed. So speed is, in this case, would be volume over time. So volume over time, this would be the speed. So they tell us it takes 7 minutes. Takes 7 minutes to fill a 30-liter gasoline tank. So the volume is 30 liters and it takes 7 minutes. So if we were to do that, we would get our answer in 30 minutes. 7 minutes, okay? 30 liters. So we get our answers in liters per minute. How many liters are filled in a minute? But they want it in gallons. No, sorry, I'm saying liters. It's 30 gallons. Okay, gallons. Let me make that gallons. Yeah, should be gallons. So we assume it takes 7 minutes to fill a 30-gallon gasoline tank. Calculate the rate which is gallons per second. Okay, we'll get the answer in gallons per minute. Okay, so 30 divided by 7, let's just check. So it will be 30 divided by 7. 30. One of you have your mics on. I'm gonna check now. That's 4.2. That's 4.29. Okay, so 4.29. Okay, I just muted that person. 4.29. So the answer is 4.29 gallons per minute. So this is in gallons per minute. Okay, so we have the answer in gallons per minute. So we have the answer in gallons per minute. Apologies. So we have the speed in gallons per minute, but we want it in gallons per second. Okay, we're going to do it in, we want it in gallons per second. So how do we convert from gallons per minute to gallons per second? We need to get rid of minutes. We need to convert it to seconds. So 4.29 gallons per minute, we need to multiply it. How many minutes? We need to get rid of minutes. It's in the denominator here, so it must be in the numerator here. So it is 1 minute is equal to 60 seconds. Okay, so we're just basically dividing by 60, which will give us an answer. Minutes will get erased, so our answer will be in gallons per second. So 4.29 divided by 60. Let's see. Divided by 60. 0.05. So the answer will be 0.0715 gallons per second. Okay. So 0.0715 gallons every second. That's how fast it will, the rate in gallons per second. Now they want the rate in cubic meters per second. Okay, so now we have gallons per second. They want it in cubic meters per second. But I forgot to take the ratio. But all we need is this. Okay, if you want in cubic meters per second, I forgot to, let me just check anyway. I'll just do what 1 gallon is in, and we just do the calculation. 1 gallon, they convert it from inches, centimeters, and that. But I was just needed this part. The next part is not important. Are you just doing the A part because I wanted this one? If you just need to convert the denominator, okay? In this case, we just converted the denominator minutes to seconds, okay? In the very first problem, we converted the numerator. Well, in that case, it was just just the one unit that needs to be converted. Okay, in this case, if you really want to do part B, calculate the rate at which a tank is filled in cubic meters per second. Okay, this is what you do. Okay, the answer was in gallons per second. Okay, so you need to convert gallons to cubic meters. Okay, now you need to find out the ratio between gallons and cubic meters and meters. Okay, cubic meters. So then you just multiply by meters, cubic meters over gallons. Let me just check. I'm going to show you now. I'm going to rather just do the whole thing. B. So that is A. So part B. The answer would be is in gallons per second. It's 0.0715 in gallons per second. Now, in gallons per second, we want to get rid of gallons and convert to cubic meters. So we are going to have gallons here in the denominator and in the numerator cubic meters. Now let's check what is the relationship between gallons per meter and, let me just check the conversion rate here. Gallons to cubic meters. Gallons to cubic meters. It says here 1 gallon is equal to 0.0035 cubic meters. I'm gonna show you at the bottom. 1 gallon is equal to 0.000378 cubic meters. Okay, you just fill that in and then you multiply by that and you'll have your answer in cubic meters per second. Okay, that's all. You just check the conversion rate. That's how easy it is to convert between units. Okay, now let's continue. Our last conversion problem. I know a lot of you just like watching other people do this stuff. You need to be able to try some of these problems. So I would advise you to just get a pen ready near you so you can actually do it by yourself as well. So question 4, conversion of units. A house is 5 feet long, 26 feet wide, and has 8 feet high ceilings. Okay, so this is the dimensions of a house. And it's 5 feet long and 26 feet wide and has 8 feet high ceilings. Okay. What is the volume of the interior of the house in cubic meters and in cubic centimeters? Okay, so let's say volume is equal to length times breadth times height. Okay, now let's calculate it in feet, cubic feet. Okay, that would be 50. A house is 50 feet long, so L is 50 feet, 50 ft, multiplied by, it has a breadth, it's wide or width of 26 feet. That's same thing as breadth, width or breadth, 26 feet. And then finally it has a height of 8 feet. If you multiply that 50 times 26 times 8, let's see on the calculator, that's 50 times 26 times 8, that's 10,400 cubic feet. That is the volume, 10,400 cubic feet. Okay, now you have 10,400 cubic feet. How do you convert to? First, you need to convert it to cubic meters and then cubic centimeters. Let me just highlight the correct question. So you have 10,400 cubic feet. Now, what is the relationship between 1 foot and a meter? Okay, so 1 foot, we want to get rid of feet, so it should be underneath. So ft should be underneath, remember. So 1 foot is equal to about 0.30. Also, by the way, they will always give you this conversion. Okay, if it's not usually known, if it's not a common unit, like everyone should know that 1000 grams into 1 kilogram, that is common knowledge. But if it's not common, like not everyone knows that 1 feet is equal to, I didn't know, is equal to 1 feet is equal to 0.3048. I had to look it up. So let me just move this up a bit as well. Now remember, it is cubic feet, so you have to cube the whole ratio. Okay, you have to cube the whole ratio. Now before you multiply, this will end up canceling feet cube, so that will cancel in your answer in meters. This is in 0.3048 meters. Okay, there should be an m there, meters. Okay, so your answer will be in meters cube. Okay, so you're going to have to divide 0.3048 and by 1 and then cube it. Okay, cube it and then multiply it by 10,400. So let's do that. Let's take 0.3048 0.3048, we cube it. Well, we don't need to, well, actually first we need to divide by 1 by point, but 0.3048 divided by 1 is just 0.3. Any number divided by 1 is just the number itself. So that value there, we then have to multiply by 10,000. Multiplied by 10,400. Giving us an answer of, in cubic meters, of 294.5. That is in cubic meters. So there you've worked out from cubic feet to cubic meters. And all you did was just that you needed to know what the relationship is between 1 feet is equal to how many meters, or 1 meter is equal to how many feet. That's all you needed. You just need a relationship between the two units, the unit that you want and the unit that you actually have. Okay, so the answer is 294 294.5 cubic meters. Okay, so this is the answer. But then they want this in cubic. This is the answer in cubic meters, but now they want this in cubic centimeters. Okay, so they want, now you need to multiply this to get it in cubic centimeters. Okay, cube there. So we know we want to get rid of meters. We know that 1 meter is equal to 100 centimeters. Okay, meters will get cancelled, and your answer is going to be in centimeters. We know that 100 centimeters equal to 1 meter. And since meter is here, we need to put it in the denominator. Okay, so they can cancel out. And since it's meters cube, you need to cube the whole conversion unit. Okay, and let me move this up. I need to move this up. Yeah. So 100 divided by 1 is 100, and then you cube 100 is 1 million. So the answer will be, in cubic meter, in cubic centimeters, the answer is going to be 294.5 294.5 multiplied by 1 million, which is 10 to the 6. That is how much it's going to be in cubic centimeters. Okay, so now you have your answer in cubic centimeters. I hope that makes sense. That is all we have for conversion of units. Okay, the reason why we did all of these problems with conversion of units is because constantly students are struggling to convert between one unit and another, because usually they are trying to memorize how to convert, like they would memorize from grams to kilograms, you need to divide by 1,000. From cubic meters, from cubic centimeters to cubic meters, we need to divide by 1 million. Okay? You don't need to actually memorize anything as long as you know one relationship between meters and centimeters, then you can do the rest. Okay, I hope that was clear. Is the Can I continue now? Mr. Lifa, Lucanio, the other Lucanio. There are two of you here. Sianda, Katiso, Bongisisa, and Ayanda. You cool? Okay, Lifa said it's cool. He understands. He's with me. Thanks there, Mr. Lifa. Okay, now we can go to order of magnitude. This is another thing. A lot of you guys, what you do is you are fixating on a problem in order of magnitude calculations. Okay, you order of magnitude calculations is estimates. Sometimes it's called estimate. Okay, it's an estimate. Okay, it is just an estimate. What we want basically is the scientific notation. You see, in scientific, I'm going to explain now what an order of magnitude calculation, or what an order of magnitude is. Okay, let's go here. Okay, see here. I'm going to highlight this thing here. Order of magnitude. This thing says the order of magnitude is the power of 10 a number is raised to when it's in scientific notation. So order of magnitude calculations has to do with scientific notation. Okay, so for example, the order of magnitude for 19,400 would be 4, because if you write it in scientific notation, it is 1.94 times 10 to the 4. So its order of magnitude is 4. Okay, so its order of magnitude is 4. It would be 4 because it is 1.94 to the power of 4. Okay, that is its order of magnitude. Okay. Now we can compare orders of magnitude for different numbers if they are put in scientific notation. For instance, check these following numbers A, B, and C. Okay, it is 6.7 times 10 to the 8. That is a order of magnitude to the power of 8. Okay, And then 6.7 times 10 to the 9 is an order of magnitude to the power of 9. And 6.7 times 10 to the 10 is an order of magnitude to the power of 10. Okay, now here, if you check out these numbers, if we look at A, B, and C, let's just look at them quickly. A, B, and C. Okay, this is to 10 to the 8, 10 to the 9, 10 to the 10. Okay, this is an order of magnitude of 8, this is an order of magnitude of 9, and an order of magnitude of 10. Okay, but this one, 10 to the 9, is one order of magnitude higher than that one. This one is one order of magnitude higher than that one. Okay, that is how we work with order of magnitudes. Okay, for instance, C is two orders of magnitude bigger or higher than two orders of magnitude higher than A. It is 100 times smaller, but it is two orders of magnitude larger or bigger. So that is how an order of magnitude works. Okay, it has to do with the power of 10. Okay, so to work with order of magnitude calculations, you first need to put in scientific notation. Okay, now if it's to the power of 6, if it's to the power of 7, if it's to the power of 8, that 6, 7, or 8 would be that number's order of magnitude. Okay, so in this case, we had the example of A. Let's say in A here, it is 6.7 times 10 to the power of 8. It has an order of magnitude of 8. Okay, now to compare orders of magnitude, let's say here, I'm going to write here, uh, let's say Avogadro's number 6.023. I haven't written this number in a long time. I hope I still remember it. 20 to the 23. I don't know if this is Avogadro's number, but nonetheless, this is an order of magnitude to the power of 23. Okay, this is an order of magnitude to the 23. Okay, its order of magnitude would be 23 because it's 10 to the 23. This is its order of magnitude. But now let's look at this number, 7 times 10 to the 27. Okay, this number we know is larger than this number. Okay, we know that 7 times 10 to the 24, 7 times 10 to the 27 is larger. We know that 7 times 10 to the 27 is larger than 6,023 times 10 to the 23. We know that this number is larger, but how do we say it's larger? We say it is, let's subtract the 27 from 23. We say it's 4 orders of magnitude larger. Okay, because this number is to the order of 23, this one to the order of 27. So this number is 4 orders of magnitude, 4 orders of magnitude, 4 orders of magnitude larger. So orders of magnitude has to do with, so it's 4 orders of magnitude larger because this one is 23. Right? So orders of magnitude calculations has to do with, to the powers, to do with scientific notation and raising a number to the power of 10. Okay? So when 7 times 10 to the 27 is 4 orders of magnitude larger, we ignore what is written in front, the 6 and the 7. Okay, those we can ignore. We are only interested in the numbers that 10 is raised to. Okay, so 10 to the 27 and 10 to the 23 means that this number is 10 to the 27 is larger because it has 27 zeros. Is multiplied by 10 to the 27 zeros with 1 with 27 zeros behind it, and then this one 23 zeros, which means the first one is larger. How much larger? It is 4 orders of magnitude larger. Okay, does that make sense? Okay, we only deal with, I see someone wrote something in the chat, we only deal with scientific notation. when dealing with orders of magnitude. That is the only important thing. We only look at the scientific notation. And someone has said that they can't see the screen. Uh, can you guys see my screen? Can I just, by a show of hands, if you can see my screen? Can someone just give me a thumbs up if you can see my screen still? Okay, okay, cool. Uh, so we now have a basic understanding of Bongisisa. And I see you've acted, there are two accounts here for Bongisisa. Oh, this is another Bongisisa. Cool. That's cool. Now, anyway, you guys can lower your hands now. Thank you. Uh, so here we have. So what in essence I'm trying to say is when you're dealing with an order of magnitude calculation, all you need to do is to check, write it in scientific notation, and then the number that the 10 is raised to would be your order of magnitude. Okay, so in this case it is 7 times 10 to the 27, so it is 27. So 27 is its order of magnitude. Okay, when you're comparing orders of magnitude, when you're comparing two values, you look at their scientific notation. Okay, specifically the number that 10 is raised to. Okay, and then if you subtract those two numbers, then the one would either be larger or smaller by that difference. Okay, by that order of magnitude of difference. Okay, now let's look at the problem, or let's look at what I've written there. It says the order of magnitude is the power of 10 a number is raised to when it's in scientific notation. Okay. For example, the order of magnitude for 19,400 would be 4 because it's 1.94 times 10 to the 4. So the order of magnitude is 4. This is be converted to scientific notation. It is 1.94 times 10 to the 4. 10 is being raised to the fourth power. And then I give you this example here. We can compare it. Now, how to make an order of magnitude estimate? Okay, you put the numbers in scientific notation. You round it up to the nearest power of 10 or integer times a power of 10. You do your calculation using these estimates, and then you compare if you have the exact answer. But that's just some steps. You can write it down if you want, but it is not really necessary. But if you want to, I just put it in there, included it. Let's look at question problem number 5. uh Find a problem. I have a problem with questions like these because of the following. Okay, what constitutes a typical sized room? Okay, many of us have rooms that are different. Okay, there is no standard room size. Okay, all rooms are different. In this case, all of these answers will have different values. What we are interested in is your answer in terms of to the power of 10. Okay, so let's look at this question. Well, let me look at this question. You see, they say find the order of magnitude of the number of table tennis balls, or another name for table tennis ball is the ping pong ball. Okay, so we have how would we go about calculating the volume of the number of rooms, or determining how many tennis balls can fit into a room? So first you need the volume of the room, then you're going to need the volume of one ping pong ball, and then you can divide the volume of the room by the volume of one ping pong ball, and that will give you the number of ping pong balls that might fit into that room. Okay, now many people actually go a bit frantic about these type of questions because they start panicking. What is the exact size of a typical room? I don't know the size of um, a table tennis ball. those things must be provided for you. Okay, if they're not provided, then whatever answer you give, if you do the correct, should be correct, because who is to say what a typical sized room is? Who is this? If they have not provided you with a table tennis ball, okay, try to estimate how big is a table tennis ball if you've seen one before. So let's first calculate the volume of a room, of a typical sized room. Now, and I stress this, can't stress this enough. Okay, volume is length times width times height. Okay, now a typical sized room for me is not going to be a typical sized room for you. Okay, I'm going to give you some values that I have. Okay, so let's say the length of the room. Let me guess. I'm sitting in a room here and I'm trying to just look at it and guess. That's about 1, 2, 3, about 6 meters. It is about 6 meters. Its width is about, let's say, 1, 2, 3, about 4 meters. Now I'm just using the room around me at the moment. Its height, say, 5 meters. This is a typical room for me as I'm sitting in. It's going to be different for each one of you. Now let's say 6 times 5, that is 30, times 4, that is 120. I'm lying. 6 times 4. 6 times 5 is 30, times 4. Why is my brain not braining at the moment? Okay, that is 20. 20 times 6 is 120. Yes, it is 120 cubic meters. That's meter times meter times meter. Okay, I had a little brain fart moment there. Okay, so we have the volume of a typical room as 120 meters. Now let's calculate the volume of a ping pong ball. Okay, I checked this actually out. I checked the diameter of ping pong ball. A ping pong ball is about, apparently it's about 3 centimeters. Okay, 3 centimeters. That's about this thing. So a ping pong ball has a radius, or would that be its radius, or let's say then 2 centimeter radius. Oh, let me just make sure. Instead of lying to, let me just go online and check what is the volume or the radius of a ping pong ball. Volume of a ping pong ball. Volume of a ping pong ball or table tennis ball. Can whatever you decide to search for. Actually searched for the volume. Should have just checked its diameter. It has a volume of 3 times 10 to the 5 meter. So volume of a ball. So the volume of the ball, they actually give it to us. You can check it online, or if you can guess the radius, you can do that as well. But I'm just going to use this 3 times 10 to the negative 5 cubic meters. So that's the volume of a ping pong ball. Correct. Now they want us, the problem asked us to calculate. So we have the volume of a room here, and we have the volume of a ping pong ball. They wanted to know how many of the ping pong balls would fit into this room if the room is, say, empty. There's no couches, no beds, nothing there, and we just want to stuff the room with ping pong balls without the ping pong balls being squished or crushed. Okay, so the number of balls would be equal to the volume of the room divided by the volume of a single ball, and that's going to be equal to 120 cubic meters divided by 3 times 10 to the negative 5 cubic meters. Remember, we're only going to do this one, and that will give us an answer of, if we work it out, we get an answer of 120 divided by, let's just do the question, 120 divided by, where is my 10 to the 5, so 120 divided by 3, that's 40, so it's going to be 40, that's to the 0, so 40 times 10 to the 5, that would be then 4 times 10 to the 6, so 4 times 10 to the 6, 4 times 10 to the 6, so there you have it, 4 times 10 to the 6, okay, so 4 times 10 to the 6 balls would fit into a room, okay, so its order of magnitude is 6, order of magnitude is 6, and that is basically how order of magnitude question work. It's just basically the scientific notation, okay. Now continue with what most of you are probably here for, significant figures and how to do operations on them, okay, how to spot the number of significant figures and how to do operations using these significant figures. Significant figures. So we have significant figures. A. First, tell me how many significant figures are in each one of these questions. Okay, so A, B, C, and D. Okay, how many significant figures? How many significant figures are there? This is question number 7, by the way. It's question 7. How many significant figures are there in each one of these numbers that are listed there? Let's look at the first one. Okay? The first number is 78,9 plus minus 0.2. Okay. Now, a lot of people tend to look at this number and add it here. This number just says that there is an uncertainty in the first decimal number, meaning there's an uncertainty in this number here. So the actual number has 1, 2, 3. This just says there's an uncertainty in this number. So this number has 3 significant figures. 3 significant figures. Okay? Try to work out as you go along how many significant figures there are. Okay? Can someone tell me for number B how many significant figures? For B, how many significant figures? If it's scientific notation, it's easy to spot how many significant figures. Can someone tell me how many significant figures there are in this number? Number B. Anyone let me know how many significant figures? You can count them out. It's 1, 2, 3, 4. Okay, so there are 4 significant figures here in this number. 4 significant figures. Let's look at third number. 2.46 times 10 to the negative 6. How many significant figures here? All you do is you count the numbers before the multiply by 10 to the minus 6 value. Okay, so it's 1, 2, 3 significant figures. So that would be 3 significant figures. Now, for the last one, number D, the number of significant figures in 0.0053. Remember, the rule says leading zeros are not significant. So then the significant figures are 1, 2. Okay, so there are 2 significant figures here. Okay, I've tried to give you a variety. I've given you a value with an uncertainty here, a value with a positive number, negative, and then a decimal number. Okay, this is the variety that I've given you and the number of significant figures. Okay, and what you take into account for. Okay. So in an uncertain, so a number with an uncertainty, the uncertainty will only tell you the uncertainty in one of these numbers here. So this number will tell you how many significant figures are, the actual number. And when dealing with scientific notation values, the number in front of the times 10 will always tell you how many significant figures there are. And same here in general for negative exponent, and then leading zeros and then trailing zeros are not significant, so hence 2 significant figures in this one. Now that is easy enough. Now what to do when we have to do calculations with significant figures? Okay, what to do when dealing with calculations involving the number of significant figures? I'm going to do a multiplication, which is the same as division. Okay, multiplication and division are the same thing. In division, you're multiplying by 1 over a value, and adding and subtraction is also the same. The same rules apply to both. Let me just check something. So question 7. Now, what do we just do question? We just did question 6. Sorry, I wrote 7 there. That was 6. So this is actually question 7. It doesn't matter which question it is, as long as we do it. Arithmetic operation. So significant figures in arithmetic operations, meaning when you're adding and multiplying, how do we deal with the significant figures? Okay, so carry out the answer, the arithmetic operation, the sum of 7, 5, 6 plus 37.2 plus 0.83 plus 2. So that is, we need to sum that. Okay, we're going to get an answer, but what, okay, let me just say this is A for number 7. How many significant figures will our answer have? What does the rule say? What does the rule say? The rule says when you're adding or subtracting, the answer will have the same number of decimal places. Remember, adding and subtracting, you're looking at decimal places. Okay, so when you're adding or subtracting, your answer will have the same number of decimal places as the number with the fewest decimal places. In this case, the one with the fewest decimal places is 2. It has 0 decimal places. So your answer will have 0 decimal places. So you're going to have to round your answer until it has 0 decimal places. Let's look at it. So let's do the calculation. Okay, 756 plus also 756 as 0 decimal places plus 0.83 plus 2. So your answer 758.83. No, I must, oh yeah, I missed one here. 37.2 plus 37.2, I missed that one. So the answer is 796.03. Now, when adding or subtracting, the answer will have the same number of decimal places as the one with the least number of decimal places. In this case, the number 2 and the number 756 has 0 decimal places. So the answer will have 0 decimal places. So it's going to be 796. When you round it off, it's 796 with 0 decimal places. That's it. B, it says multiply 0.0032 by 356.3. Let's just check how many significant figures. 2 significant figures here and 1, 2, 3, 4 significant figures. Now, from our rules of significant figures, we know when we are multiplying or dividing, the answer will have the same number of significant figures as the number with the least amount of significant figures. In this case, the one with the least amount of significant figures is 0.032. It has 2 significant figures. So the answer will have 2 significant figures. So let's multiply that out and check. We must find an answer with 2 significant figures. 0032 multiplied by 356.3. So the answer must have 2 significant figures because the answer must have the same number of significant figures as the number with the least amount of significant figures. In this case, this first number has 2 significant figures, so the answer must have 2 significant figures. So if this is the answer that we get. You check there on your calculator there at the bottom of the screen. The answer is 1.14016. So if you reduce it to 2 significant figures, it's 1.1. Okay, that is the rule. Finally, we check our last one, C. It is 5.620 multiplied by pi. Pi has an infinite amount of significant figures. So there is an infinite amount of significant figures, and this one has 4 significant figures. So the answer will have 4 significant figures. Okay, if you multiply it out, let's just check. Clear? Where's pi here? Let me try to find pi. Functions supposed to be here. Oh, there it is. Pi multiplied by 5. Multiplication is commutative, so I can do this. 5.620. It is 17.6, but the answer will have 4 significant figures, so it's 17.66. Okay, because the answer must have 4 significant figures. The answer must have 4 significant figures. And that is all that we have today. Guys, thank you so much for joining me, and I hope you have a pleasant rest of your day. Okay, all the best, and I'll see you next week, Tuesday. I hope you have learned something, and if you have misunderstood something or I haven't explained clearly, please let me know now before you leave or before I log off. And if you want to recheck it, the video will be available on YouTube. I am trying to upload recordings nowadays because some of them buffer. Okay, thank you very much and have a good day.